Hey friends, this is Vidhan. Welcome you to my channel. Today we will see a problem from December 2016. Booklet code A, question number 64. The problem is on operational amplifier. In the circuit below, the input voltage Vi is 2 volt. This is 2 volt DC supply. VCC 16 volt. That means here plus 16, minus 16. Although minus 16 has not been shown here. R2 is 2 kilo ohm and RL is 10 kilo ohm. RL is the load resistance. This value is 10 kilo ohm as given in the problem. The value of R1 required to deliver 10 milliwatt of power across RL is, that means what should be the value of the resistance R1 such that there is a power consumption of 10 milliwatt by this resistor RL. This is the question. Since there is a power consumption as given in the problem, then let me tell you that there must be a current flowing through this resistance RL. What do I mean? The meaning is that power consumption in a circuit is only possible when there is a current in the circuit. And if there is no current in the circuit, then power consumption is not possible. This is very important concept. Power is generally related to the current. And it happens so that if the current is higher, power consumption is higher. If current is lower, the power consumption is lower. And this is the reason that when we make a circuit by using a battery, wire and a resistor, then we try to keep the resistance as high as possible so that the current is as low as possible, and when the current is low, then the power consumption is low and the battery that we have used will last for a very long time. But if we choose the resistance to be very low, then for the same battery the current in the circuit will be very high, and when the current is high, then the power dissipation or the power consumption will be very high. And when the power is high, then the battery I have used will not last for more than few days. So this is very important, and this is what we generally keep in our mind when we make circuits. What I said, that if there is a power consumption as has been said, so there is a current through this, and if there is a current through this, there must be a voltage difference, because without voltage difference and without its dropping, there cannot be a current. So there is a voltage, and this voltage is which voltage? This voltage is actually the output voltage of this operational amplifier circuit, because this is what is coming to this point available across this resistance RL. We have to find the value of R1. This is actually the feedback resistance. Now if we want to find the value of R1, what we need to do, we need to write down the output formula for this circuit. And in the output formula there is R1, that means feedback resistance. So we have to know V output directly, not by using the formula, but already we need to know what is the V output, and in the formula there is R1, and from that output we will find this R1. This is the concept. And how can we directly know the output not using this circuit? Because this condition of power dissipation or this condition of power consumption has been given. Using this we know power equal to V into I. Using this we can find the V, and this V is V output, because this is the this output is the voltage that is dropping across this RL. Now if we want to write down the formula for output, we must know what circuit is this, because we know the output formula for inverter circuit is different, for non-inverter circuit is different, and for differential circuit is different. We know that there is a feedback circuit, so whatever is the output, this output will be for the feedback circuit. But which one is this? I must know that. Now this looks very complex. Let me tell you that this is the non-inverter circuit, non-inverter operational amplifier circuit with feedback. Now this may be looking to be a very complex circuit, and it doesn't seem to be a non-inverter circuit with feedback. But let me tell you that this is non-inverter circuit, and for that I will tell you how this is non-inverter circuit, and for that I will do step-by-step simplification of this circuit. So somehow we have to come at a conclusion that what circuit it is, and I already know that this is a non-inverter circuit. Okay, let me show you. For this I have already drawn the circuit on my board. So here is the circuit. This is the circuit that has been given in our problem, and here obviously finally there would be an output V0, and this output would be going to RL and R1 as well, and same voltage at this point also V0, and at this point also the output V0, because these and these are in parallel. Now see, look here, that again for this circuit there will be output V0, and whatever is the voltage at this point would be the voltage at this point. So through this RL the voltage is again V0, the same voltage, and through this R1 circuit this is V0. Just similar to this, that same V0 going through R1 and going through RL. That means this circuit that has been given in our problem, I can write this, or I can draw this circuit or simplify this circuit in this manner. In this way I can write it down. Now this circuit I can write in this way. And how? See, I have done no change. There is no change in the configuration. From positive terminal Vi grounded, from positive terminal Vi grounded, from negative R2 grounded, from negative R2 grounded, and before R2 there is a circuit with R1, and before R2 there is a circuit with R1, RL. So it's just same to this. One thing we have done, that here it is in a bent shape, but I have just stretched it out. Okay, now this circuit is again same to this circuit. What I have done, I have just flipped it. You can see the positive side is upward, now the positive side is downward, but otherwise everything is same. I cannot change any the configuration, because whatever has been given in our problem, those things must be retained, and we are not allowed to change those things. Just what I am doing, I am just simplifying these things, the look of the circuit. So the same things are still there. From plus terminal Vi grounded, from plus Vi grounded, from negative R2 grounded, from negative R2 grounded, and before R2 there is a circuit with R1 going to output. Before R2 there is a circuit with R1 going to output, RL. Same things. And now looking at this circuit, we can understand that this is a non-inverter circuit, obviously with feedback, and where feedback resistance is R1, and this resistance that we call R1 is actually R2 as given in our problem. But since the input voltage Vi is being given to the positive terminal and there is a feedback, so it is non-inverter with a feedback. That means this is the question, and from here I have told you that this circuit is actually this circuit. So even if you don't simplify it, from here you can understand by watching it closely that it is a non-inverter circuit. Well, I have simplified it, but this is the non-inverter circuit. Now what is the output for non-inverter circuit with a feedback? The output is this, 1 plus Rf by R1 into V input. Now in our problem the Rf is equal to R1, so we have written 1 plus R1 by R1, and R1 is actually R2 as given in our problem, so it is R2 into V in, and V input is Vi, so Vi. So this is our output. Now let me write down again the output, 1 plus R1 by R2. This is actually feedback resistance R1, and this is what we have to find. into Vi. Now we have to find R1, R2 is given, Vi is given. If we can find V0, then everything is done. We can find R1. So let us write down V0 is equals to 1 plus R1 by R2 is 2 kilo ohm. So it is 2000. Vi is 2 volt into 2. That means everything is ready. Just we have to find V0. How to find V0? By using that power consumption condition. So power is equals to V into I, and V is actually V0 because the output voltage is the voltage that is available across the load resistor and the power is consumed there. So if I want to find V0, I have to do P by I, and power is given, but I is not given. So if I is not given, how can I find V0? So for that, first of all, I have to find the I. And how to find I? Again we will use the power formula. Okay, later we will come to this, to voltage, but first of all again we use power formula V0 into I. And now we will break this V0 in terms of Ohm's law, that is I into RRL, because this voltage is going to load resistance into I. That means I square RL. And power is what? 10 milliwatt. That means 10 into 10 to the power minus 3 watt into I square, and RL is 10 kilo ohm. So it is 10 into 10 to the power 3. It is 10 to the power minus 2 equal to by 10 to the power 4, and we take it downside. So I is equals to, and this is what? This term is 10 to the power minus 6. Okay, I square is 10 to the power minus 6. Then I is equals to root over 10 to the power minus 6, and it is 10 to the power minus 3 I. So using the same law and here the Ohm's law, we found out at first the I current through the load resistance, and now we plug this I here. Again the power formula. So power again 10 milliwatt, that means 10 into 10 to the power minus 3 equal to V0 into I, and I is 10 to the power minus 3. Now V0 is equals to, this is 10 to the power minus 2 divided by 10 to the power minus 3. So it is 10 to the power 1. Yeah, it is 10. So V0 is equals to 10 volt. Okay, so we have found out the voltage, output voltage of this circuit. So found out the output voltage of this circuit by using that power consumption situation. But we have here, we need to find R1, and we have this situation. So V0 we have known and everything is known, just R1 we have to find. So again we use this. Let me write down below. This is V0 is equals to 1 plus R1 by 2000, because R2 was 2000 into 2. Now V0 is what? V0 is 10 volt. So 10 is equals to 1 plus R1 by 2000. This cuts by 5. 5 is equals to 1 plus R1 by 2000. 5 minus 1, take this left hand side to the left side, is equals to R1 by 2000. That means 4 is equals to R1 by 2000. Then R1 is equals to 4 into 2000 is equals to R1, and that means 8000 ohm is equals to R1. And what is 8000 ohm? 8000 means 8 kilo ohm. R1 is equals to 8 kilo ohm. So this is it, and our answer is 3. So when this R1, that means the feedback resistance, that means here the feedback resistance is 8 kilo ohm, then the voltage will be 10 volt as we found here, and in that case only the current will flow across RL such that there will be a power consumption of 10 milliwatt. So this is the answer, and for now our answer is 3. So answer is 3. Thank you.